An 800 amp circuit breaker carrying a load of approximately 720 amps is experiencing overheating. The breaker case is warm to the touch. A thermographic survey found no temperature variances other than the temperature of the breaker itself. The breaker is relatively new, about 4 months old. The previous breaker also exhibited the same temperature rise. The ambient temperature of the electrical room is between 60 and 90 degrees Fahrenheit, and there's a 120 volts fan on the motor control center door to help with heat. This heating characteristic is unique to this breaker in the electrical room. The load consists of lighting transformers, panels, and typical motor loads, with no apparent harmonic distortion sources such as variable frequency drives. Possible causes for the overheating include loose or dirty connections. It's crucial to check all connections at the line and load terminals as well as the bus bars. Loose or contaminated connections can create resistance, leading to increased heating. While the load of 720 amps is slightly below the breaker's 800 amps rating, continuous high load levels can still cause excessive heat, especially if the breaker is constantly near its maximum capacity. An internal fault within the breaker could be another reason. A small, intermittent fault can cause localized heating, which may be challenging to detect through thermographic surveys. Even with the fan on the motor control center door, the electrical room may still suffer from inadequate ventilation. Heat buildup from other equipment or poor airflow can contribute to the breaker's high temperature. The quality of the new breaker could also be a factor. A substandard breaker or a manufacturing defect can affect its thermal performance. While the load is described as lighting transformers, panels, and normal motor loads, there might be unknown characteristics or harmonics present that are not being accounted for. To troubleshoot the issue, firstly, inspect and tighten all connections at the breaker and bus bars. Secondly, monitor the load current over time to ensure it remains below the breaker rating. Thirdly, contact Cutler-Hammer technical support to inquire about any known issues or recommendations for this specific breaker model. Fourthly, improve ventilation in the electrical room by installing additional fans or vents. Fifthly, consider replacing the breaker with a higher rated model to reduce thermal stress. Sixthly, conduct further diagnostic tests such as impedance testing or partial discharge monitoring to detect any potential internal faults. Begin by thoroughly inspecting and tightening all electrical connections associated with the breaker. This includes the connections at the line side where power enters the breaker and the load side where power exits to feed the connected equipment. Pay close attention to the busbar connections, ensuring they are clean and properly torqued. Use calibrated torque wrenches to tighten connections to the manufacturer's specified torque values. Loose connections create increased resistance, which generates heat. Higher resistance connections can also lead to arcing, which is a dangerous condition that can damage equipment and potentially cause a fire. Cleaning corroded or dirty connections is essential. Use a specialized electrical contact cleaner to remove any buildup of oxidation or contaminants that may be present on the contact surfaces. After cleaning, apply a thin layer of antioxidant joint compound to the connection surfaces to prevent future corrosion. Monitor the load current flowing through the breaker over a period of time. Use a clamp-on ammeter to measure the current on each phase of the circuit. Record the current readings at different times of the day and under varying load conditions. This will help to determine if the breaker is consistently operating near its rated capacity. If the load current is consistently high, consider redistributing the load to other circuits or upgrading the breaker to a higher amperage rating. Breakers are designed to carry their rated current continuously, but operating them near their maximum capacity for extended periods can cause excessive heat and reduce their lifespan. Contact Cutler-Hammer's technical support team. Provide them with the breaker's model number, serial number, and a detailed description of the problem. Ask them if they are aware of any known issues or common problems with this particular breaker model. They may have specific recommendations or troubleshooting steps that can help to resolve the issue. Cutler-Hammer's technical support team may also be able to provide guidance on proper breaker installation, maintenance, and testing procedures. Insufficient ventilation can trap heat inside the electrical room, causing the breaker to overheat. Evaluate the existing ventilation system to determine if it is adequate for the room size and equipment load. Consider adding additional fans or vents to improve airflow and remove excess heat. Ensure that any vents are not blocked by obstructions such as boxes or equipment. Installing exhaust fans can help to remove hot air from the room, while intake fans can bring in cooler air from outside. A properly designed ventilation system should provide a consistent flow of air throughout the electrical room, preventing hotspots from forming. If the breaker is consistently running hot despite other troubleshooting efforts, consider replacing it with a higher rated model. A higher rated breaker will have a greater capacity to handle the load current without overheating. When selecting a replacement breaker, be sure to consider the circuit's voltage, amperage, and interrupt and capacity requirements. Consult with a qualified electrical engineer or electrician to ensure that the replacement breaker is properly sized and installed. Before replacing the breaker, verify that the existing circuit is properly protected by upstream overcurrent devices such as fuses or other circuit breakers. Internal faults within the breaker can cause localized heating that is difficult to detect with thermographic surveys. Consider conducting further diagnostic tests to identify any potential internal problems. Impedance testing involves measuring the impedance of the breaker's internal components to detect any abnormalities. Partial discharge monitoring can detect small electrical discharges within the breaker, which may indicate insulation breakdown or other internal faults. These tests should be performed by a qualified electrical technician using specialized testing equipment. If any internal faults are detected, the breaker should be replaced immediately. Examine the load characteristics. While the load is described as lighting transformers, panels, and normal motor loads, there may be unknown characteristics or harmonics present that are not being accounted for. Harmonics are electrical currents or voltages that are multiples of the fundamental frequency, typically 60 Hz. Harmonics can be generated by nonlinear loads such as electronic ballasts, variable frequency drives, and uninterruptible power supplies. Harmonic currents can cause overheating in electrical equipment, including circuit breakers. Use a power quality analyzer to measure the harmonic content of the load current. If significant harmonics are present, consider installing harmonic filters to reduce the impact on the electrical system. Conduct thermographic surveys on the other electrical equipment in the room. This will help to identify any other potential sources of heat buildup. Pay close attention to transformers, panels, and motor starters. If any hotspots are detected, investigate the cause and take corrective action. Regular thermographic surveys can help to identify potential problems before they lead to equipment failures. Check for any signs of loose or corroded connections on other electrical equipment in the room. Tighten or clean any connections that are found to be problematic. Ensure that all electrical equipment is properly grounded. Proper grounding helps to protect against electrical shock and can also help to reduce the risk of equipment damage. Inspect the electrical room for any signs of water damage or moisture. Water damage can cause corrosion and electrical faults. Repair any leaks or sources of moisture immediately. Consider installing a dehumidifier in the electrical room to help control humidity levels. Document all troubleshooting steps and findings. This will help to track progress and identify any recurring problems. Keep a detailed record of all inspections, tests, and repairs. This information can be valuable for future troubleshooting efforts and can also be used to demonstrate compliance with safety regulations. Consult with a qualified electrical engineer or electrician. They can provide expert guidance and assistance with troubleshooting complex electrical problems. An electrical engineer or electrician can also help to ensure that all electrical work is performed safely and in accordance with applicable codes and standards. Consider implementing a regular electrical maintenance program. A well-planned maintenance program can help to prevent electrical problems from occurring in the first place. Regular maintenance should include inspections, testing, and cleaning of electrical equipment. It should also include training for employees on electrical safety procedures. Electrical safety is paramount when working with electrical equipment. Always to energize circuits before performing any work. Use appropriate personal protective equipment (PPE) such as gloves, safety glasses, and insulated tools. Follow all applicable safety procedures and regulations. If you are not qualified to work on electrical equipment, seek the assistance of a qualified electrical professional. A continuous high load, even slightly below the breaker rating, can cause heat. Consider a load study to verify actual demand. A load study involves measuring the current draw of each circuit over a period of time, typically a week or more. This data can be used to determine the actual peak demand and identify any circuits that are consistently overloaded. If the load study reveals that the breaker is operating near its maximum capacity, consider redistributing the load or upgrading the breaker to a higher amperage rating. Also consider the breaker's duty cycle. Is it constantly loaded near 720 amps, or does the load fluctuate? A fluctuating load might allow the breaker to cool down between high demand periods, whereas a constant load will generate more continuous heat. Check the breaker's time current curves to understand how it responds to different overload conditions. Time current curves show the amount of time it takes for the breaker to trip at different levels of overcurrent. This information can be helpful in determining if the breaker is operating within its design parameters. Investigate the possibility of nuisance tripping. Is the breaker tripping unexpectedly even when the load current is below its rated capacity? Nuisance tripping can be caused by a variety of factors, including voltage fluctuations, transient surges, and internal breaker problems. If the breaker is tripping frequently, it may be necessary to replace it. Also check for proper labeling. Is the breaker properly labeled with its amperage rating and voltage rating? Proper labeling is essential for safety and can help to prevent accidental overloads. Consider using thermal monitoring systems. Install temperature sensors on the breaker and other critical electrical equipment to continuously monitor their temperature. These sensors can be connected to a central monitoring system that will alert you if any abnormal temperatures are detected. Thermal monitoring systems can provide early warning of potential problems and can help to prevent equipment failures. Furthermore, consider infrared windows. Install infrared windows in the electrical panels to allow for thermographic inspections without having to open the panels. This can reduce the risk of electrical shock and can also save time and money. Infrared windows are especially useful for inspecting equipment that is difficult to access or that requires specialized tools to open. Review the breaker's maintenance schedule. Is the breaker being properly maintained according to the manufacturer's recommendations? Regular maintenance should include inspections, cleaning, and testing. Proper maintenance can help to extend the life of the breaker and prevent problems from occurring. Consult with the breaker manufacturer for specific maintenance recommendations. Consider energy audits. Conduct regular energy audits to identify opportunities to reduce energy consumption and improve the efficiency of the electrical system. Energy audits can help to identify equipment that is operating inefficiently or that is contributing to harmonic distortion. Implementing energy-saving measures can reduce the load on the electrical system and can also save money on energy bills. Remember the importance of safety training. Provide regular safety training to employees who work with electrical equipment. Safety training should cover topics such as electrical hazards, lockout/tagout procedures, and the proper use of personal protective equipment. Properly trained employees are less likely to make mistakes that could lead to electrical accidents. Also consider arc flash studies. Conduct arc flash studies to determine the potential arc flash hazard levels in the electrical system. Arc flash studies can help to identify areas where additional safety precautions are needed. Arc flash studies should be performed by a qualified electrical engineer. Consider short circuit studies. Conduct short circuit studies to determine the maximum fault current that the electrical system can withstand. Short circuit studies can help to ensure that the electrical equipment is properly protected against short circuits. Short circuit studies should be performed by a qualified electrical engineer. Review coordination studies. Review the electrical system's coordination studies to ensure that the overcurrent protective devices are properly coordinated. Coordination studies can help to prevent nuisance tripping and can also improve the reliability of the electrical system. Coordination studies should be performed by a qualified electrical engineer. Don't forget surge protection. Install surge protection devices SPD to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. SPD can help to prevent equipment damage and can also improve the reliability of the electrical system. Also look for preventative maintenance. Implement a preventative maintenance program to regularly inspect and test electrical equipment. Preventative maintenance can help to identify potential problems before they lead to equipment failures. Preventative maintenance should be performed by qualified electrical technicians. And consider power quality monitoring. Install power quality monitors to continuously monitor the quality of the electrical power. Power quality monitors can help to identify problems such as voltage sags, voltage swells, and harmonic distortion. Power quality monitoring can help to improve the reliability of the electrical system and can also prevent equipment damage.